All right, so today we're going to be creating a little project together. This one is going to be a little bit more advanced, maybe a little bit longer, but essentially we're going to use a lot of the object-oriented concepts that we've developed along with some new concepts with file input and output in order to create something that has persistence, something that could operate as like a real application. Now, it won't be terribly practical. We're going to be making a grocery list type of an application. The problem is that you're not going to take a laptop into the grocery store with you. So this whole text-based whatever, not super helpful. But I know that if you are new to programming, you won't know this or see this, but it is incredibly close to what you would have to do to put this on an iPhone or an Android phone. It's just figuring out the interface, how to get it on the screen and how to interact with the fields on the screen as opposed to writing to the console. But other than that, like the class that we're going to create is going to be pretty identical to what you would create for something that was on a mobile device or something that was something you could actually use. And so what we're going to do is we're going to start by modeling the problem, right? Creating a grocery list, and then as a class. And then after we're done modeling that, we're going to create just a quick user interface in main. This is the thing that would probably very much change when you want to switch to a specific device. As well as there'd be a few things in the class you'd want to change. Obviously, anything where we use cout, you would want to populate fields with text. But other than that, very, very similar. So let's go ahead and get started. All right, so to start with, let's go ahead and create a brand new project. We're going to call this, not Untitled, let's call it Grocery Helper. I don't know, something like that. Naming things is the hardest part of computer science, and we will go ahead and let it do its build thing. It's going to give us main CPP, but we're not going to start there. Again, we're going to use main for our user interface later on, and we'll actually create like a little menu system where you can like do different things to our list. Clearly, we've got to be able to get stuff onto the list, get stuff off the list, etc. And so all of that is going to start by modeling our problem. And so I'm going to create a new class. Let's right-click on New C++ class. That'll create both files for us. I'm going to call this class List. Let's keep it simple. And who knows, you might want to actually, I wouldn't say skin, but you may choose to make the theme of your project. It doesn't have to be a grocery list. It could be any sort of task list, to-do list, sort of a thing. And there's ways we could actually create multiple lists so that you could flip between lists. We're not going to do that because it'll take extra time, but you can expand on this. In fact, your assignment will likely be adding a feature to this whole project. So we're going to choose our name, header and implementation files, make sure we have add to targets, put on there, hit OK, and then just wait for it to create the list, which it did rather quickly. And so we're going to start with the header. I'm going to go ahead and just leave these include guards that are put in there automatically. Why not? There's no reason for us to get rid of them. In fact, we don't want to get rid of them, but we could switch to that pragma once shortcut. So what are some things I'm going to need in just the header file for this class? Things I'm going to need to include. One of the things is I'm definitely going to be using some strings. That seems logical. I'm also going to be using vectors because vectors are dynamic collections, right? They can grow, they can shrink. I don't know how big your family is. I don't know how many groceries you have. Maybe you just really like snacks, maybe whatever. So I want to have something that can grow and shrink with all of our needs. That's probably all I'm going to need. So with that, I'm going to put in my using namespace standard just because it'll make it a little bit easier for me. And then I get to defining the list. Now here's the thing. This is why you do a lot of work on a whiteboard. And I've done this project, this demo before, so it's not new to me. But something that's going to make our application much more flexible is if the list contains a collection of items that need to be purchased, right? So I'm going to have a list of items. Now I could create a whole separate class for items, and then I could have, like individual, like things that I have to do with the items. I could include functionality. I don't necessarily want to do that here though. For me, an item is just going to be a collection of data, right? It's just going to be like a sort of lumping together of some different variables. And so for me, I think a struct would be fine. And because this struct is only ever going to be used by the list, it's sort of tied to the list, I'm actually just going to define my struct right here. So I'm going to create something called an item, right, as a struct. Now, this item is going to need to include a couple things. And so for the purposes of this demo, what we're going to do is we're going to make a string for the name of the item. That would make a lot of sense. And then I'm going to want to create basically a way of determining whether or not I purchased the item, right? Picture like you have a checkbox, right? I want to be able to check boxes next to the items that I've purchased as I'm going through my grocery store. And so, yeah, it makes sense. I would just create a bool for purchased. Sure. Now we could add additional stuff to this. We could add, well, maybe a quantity, although maybe that's something you'd be thinking about later on. Anything else? Maybe there's a difference between like an item and a brand or something like that. At this point, I think name and whether or not it was purchased is going to be enough. But by putting that information into a struct, I've made it so that each line item in my grocery list has flexibility. I can add on to it. I can make it more complex later on if I want to. If I just used a string for items, I'd have to create this struct and do a whole bunch of other stuff. Really what I'm saying is I'm setting you up to make the project for this week much easier later on by doing this. Now that I've got items, I can actually go through and create my list. So for the list, I need to create, well, something, right? I need to have at least one private member, and that's going to be a vector that holds items. Now I can do this because I've already declared items above the list. So where do you need to declare the struct? You could declare it after the class, but in this case, the class involves items, so I want to make sure that I have that done beforehand. And then I just need to give it a name. Items. Let's keep it simple, right? I have a vector of item objects called items, and that's where I will store all of my list items that I will eventually write to a file, and then when you reopen the application, it will load from that file so that none of your items are missing. That may actually be all I need. If we wanted to create something where lists had, like you had different types of lists, then maybe we actually create a title for this list so that you can actually load different lists by title. I'm not going to deal with that right now. Might be a fun side project, but for right now, we're going to keep it simple. Now I need to be able to do some things with my list. First thing I need to do is actually create one. So I'm going to create a default constructor for lists. In fact, I'm going to actually label these just because I feel like it might actually be helpful as projects get bigger. So this is where my constructors are. I don't really need to create actually any other constructors. I can't think of like creating a list where I'm already adding items at the point that I create it. I just want to create a list. So that should be sufficient for constructors. In terms of getters and setters, well, there I just need to actually create something that can, well, actually, I probably don't need any because I don't have titles. So the idea of sort of getting or setting that vector doesn't really make a whole lot of sense. I can do some work in the constructor for that, but I'm really not going to need it. So I'm going to skip it. But in case you needed it, I would put them there. The next thing I'm going to do are my actions, things that I actually want to be able to do with these lists. So one of the things that I might want to do is display the list. That makes a ton of sense. So void display, and this is where we'll do our input, output, arts, and crafts to put something on the screen. That'll be different. I'm going to need to be able to add a task, right, or add an item to my list. So let's go ahead and say I want to void add item, and then you have to be able to add an item, so let's make it a string with item, lowercase I item in this case. So then I can add an item. I probably want to be able to remove an item as well. Now I could have you actually type out the name of the item you want to remove. What I'd probably rather do is just display it, and when we display it, we'll have numbers next to it, so you can just select a number. We could actually create multiple remove items that do the exact same thing. So let's say remove item, and in this case, I just want an int with the index of the item. Let's see here. How about we need to mark as purchased, right? So if I'm going to mark as purchased, that is going to probably also take, we'll do it the same way we do remove. We'll see the list, you'll have numbers next to it, you choose a number. Now you could also have them actually type out the name, but then you have to worry about, well, did they get the capitalization right? Did they misspell something? Choosing a number is a little bit easier when we're doing our little menu system. So we're going to say mark as purchased, and that will also take an index. Let's see here, what else? We should be able to remove an item altogether. Oh, we already did remove item. So I need to be able to mark as unpurchased. Like what if I check a box accidentally? I don't want to remove the item and have to re-add it just to get rid of the checkbox. I want to be able to uncheck the checkbox. So we'll say mark as unpurchased. I'm telling you, naming things is the hardest part of computer science. So mark as purchased, mark as unpurchased. That'll be undoing the checkbox. What else do we need to do to our list? Oh, I know. We need to be able to actually load and store, which is the whole point of this entire exercise. So this is also not going to return anything. We'll just say load and store. Now load and store will be fine as they are because we're only going to have one file with one list. If you wanted to make it more complex, you could choose store and actually send a string with the name of the list, which would be somehow appended to that file name so that we could get the right file back. But for right now, this is how we're going to create persistence. We're going to load and store our list of items somehow to a file on our hard drives. So that should be all that I actually need to do for this list to work. Next, we just need to implement it. All right, so here we are in our implementation file. You'll notice the first thing we've done is, or what's already been done for us, is to include the header file for lists. So we're going to need that. We're also going to need to include some other stuff. Let's see here. We're going to need, IO stream for certain. We're going to need to include strings and include vectors. And let's see here, what else? We're going to need fstream, which is going to be our file stream object. So that is typing on an elevated laptop. Fstream is going to allow us to do all of our file input and output, so we need that. Let's see. I think that's probably it, right? We can go back to using namespace standard, and now we can actually just start implementing stuff. Now, my favorite way to implement stuff is to start with my little list of things here and copy paste. Oops. Apparently I typed in that last curly brace manually. C-line did it for me. So, you know, fully automatic. I should have known. All right, so now I've got my list of things that I need to do. Let's start with the constructor. Now, as it turns out, I actually don't need to do anything with this. I've simplified this project down to the point where there is nothing in the constructor to do. If the list had a title, anything like that, we would want to set those things there. As it turns out, the only thing that we have is a vector, and we want the vector to start blank when you first create the list. So we don't really need to do anything. We're not adding anything to that vector of items. So the constructor remains blank. We at least have it there so that it exists. It just doesn't do any initialization. And, you know, if you needed to do something as you're adding features later, you could put something there, although you may not need to. Getters and setters, we don't have any. But again, you know, nothing wrong with having something there, just in case. And then let's start working on these. So now this is a member of the list class. And we are going to convert display. Basically with display, I just need to actually display a list. So displaying a list is really just going to be to the screen. This is not at all anything that's going to be written to the console. So I'm going to start out with a bunch of these things. So we can have a nice little list here. New line character, sounds reasonable. Kind of line this up. Next thing I'm going to send is maybe a string that says grocery list with a new line character. I'm going to go ahead and just copy this so that my little slightly OCD brain will know that those are going to be the same length when they go across. And so now I need to actually display the list. So yeah, there's going to be a couple ways we could do this, depending on how we want to traverse that vector. We could either do it with the range-based sort of for loop, which would just be, you know, for item and items, something like that. But we could also do it with iterators and actually go through the items individually. Now, as it turns out, either way, I'm not going to get something that I want, which is a number. I just want to number the items in our list, which seems really simple, but both iterators and, you know, using a ranged-based for loop are going to do this in the exact same way, right? Like we're going to have to create our own number system to go with. So I'm going to say int n equals 1, because that'll be the first item in our list when we start printing them out. And then I'm just going to use a for loop to go through the lists. So for item in items. So that's a ranged-based for loop. Vectors or arrays works the same way. We're going to essentially go through the items list. I usually do space before and after the colon, although it's not strictly needed in the syntax. And so we're going to go through the items vector, and each time we encounter a new element, we're going to copy that element over to item, and then do whatever from there. What we could do, if we didn't want to copy, in this case, we could put an ampersand there. What that'll do is that'll actually just give us an alias item, which will point to the original item that exists in memory already. That's a little bit more efficient for a beginning class. I would not expect you to do that, but you can if you want to. Put a little ampersand there, and you're going to get a you're going to get an alias to the original string, or I should say item struct, rather than copying stuff over. So we'll call that a little bit more efficient. We'll do it. Now for each of these things, I need to actually print out something. So we're going to cout onto the screen. First thing we're going to do is cout in, maybe with a period and a space afterwards. I feel like that's probably the way to go. You can format this any way you want. This is, again, input, output, arts, and crafts. You are in charge of your own glue stick. You can do this however you want. Now that I think about it, I kind of like to have the checkbox right there, like in front of the name of the item. That way the checkboxes are all sort of lined up nicely on the screen. So I'm actually going to put a square bracket there. And now I need to print something else to the screen, right? Basically what I want to do is I want to put a capital X if the item has been purchased already, or a blank, a space, if it has not been purchased. So there's a lot of different ways I could do this. I could break this out now into like an if-else statement. That would work. This is one of those situations where it is so concise that I'm perfectly happy using the ternary operator. Now I'm going to put the ternary operator in parentheses because I'm not entirely sure where the ternary operator fits in the order of operations with the arrow. Again, just because you know mathematical order of operations doesn't mean C++ has its own system. But by putting in parentheses, I know that I'm safe. So what I can do is I can say item.purchased. That is a Boolean in and of itself. It's going to have a value true or false, right? So the ternary operator essentially says question mark after that, based on the evaluating that and coming up with true or false, I can put in a value if true. So if it has been purchased, I want to print a capital X, colon, a value if false. I'm going to do a space. I'm going to actually put a space in there. That way my square brackets still line up and it forms a little box. Again, you can do this any way you want, but it's just the way that I'm going with it. And then I have to do my closing square bracket and probably a space. I'm going to run out of room on my screen just because I'm using a slightly larger font for the video. So I'm going to drop this down, even though this is still on one line. I have not done a new line yet. So we're still printing to just one line. Next thing I need to do is item.name. We'll print that to the screen. And then after that, well, that's really it, isn't it? That's all we have. If there were anything else we wanted to put in here, like let's say later on you want to do a quantity, maybe you'd have to put in like, a little X and then the number of items that you wanted to buy. So it's like, oh, I know I need to buy, I have 2 jars of peanut butter and yada yada. But here I'm just going to do the name, and so then I can just finish this with an inline. I'm not in the middle of a string. If I were in the middle of a string, I'd do my \n for new line. They're irrelevant. You can do this either way. You do it that way too. We just need to get a new line in there. Both quote / in quote is 4 characters, and ENDL is also 4 characters, but ENDL is just a little faster to type. So if I'm not already in the middle of a string, I often use ENDL. But you do what you want to do. Next thing I want to do in this for loop is increment in, because we want to increment as we go down, right? So the next item will be item number 2. And remember, the reason we need those numbers is because we decided we were going to use numbers to remove items and to mark items as purchased. So having the display with the numbers there will be helpful for us. Other than that, we're pretty much done. The last thing I'm going to do is do a cout real quick and just paste another one of those lines from above so that, kind of creates a nice border for our list. It'll be line, grocery list, line, all the items numbered, and then another little thing of lines. All right, cool. Then we've got that done. Next thing we need to do is to add item. Go to the next one on our list. First thing I should say is this, because we're in a separate file, is a member of the list class. Then put our curly braces, instead of the semicolon, and now I can implement the add item. So to add an item, that means that you're going to be giving me an item. So I need to do something with that. You've given me a string, which tells me that, okay, so whatever I'm doing in the interface over in main, you've already been asked what item you want to add, and you're now just adding it to the list. So then all I have to do is create a new item. So item noob. That's as good a name as anything else. And then I just have to fill in the name field of noob with the string that you gave me. So let's say noob.name equals item, the item that you sent me. Noob also has another field, right? So noob.purchased equals false. I'm just going to go ahead and set a default value for that. C++ does not automatically set values for your fields, and so I want to make sure that they're all filled out, right? So you just added it. Clearly you have not purchased it yet. We're just going to make that the default behavior. So now I've got my fields filled out. So now I need to say items.pushback and send it the noob object that I just created. Right? So that will add the item that you gave me to the vector that holds all the items. At this point, I think we're good. So let's talk about removing an item next. Okay, so there's a couple different ways we can remove an item. The first would be to do it manually, right? We could just create an iterator, go to the location of the item, and then go to the next item, and then sort of swap places and sort of copy items down to sort of truncate everything. Now, vectors already have, if you checked out the information from last week, an insert method and an erase method. Insert will essentially insert a new object at any particular position using an iterator, and it will then push all the elements to the, if you're picturing it, to the right of that element, right, out to make room for the element. So if I want this to be the third element, it'll put it into the third place, and whatever was third place will become fourth, whatever was fourth will become fifth, whatever was fifth will become sixth, etc. Remove item is going to use erase. Erase does kind of the same thing. It's just that if I remove item number 3, right, the third element, I should say, if I remove the third element, then whatever was the fourth element will become the third element. Whatever was the fifth element will become the fourth element. Essentially, everything collapses down to take up the space when I got rid of that one item. So that's what we're going to use for remove item, because it's a lot faster than doing it manually, and vectors have it built in, so why not? Also, it'll give us a chance to play with iterators a little bit. So remember, an iterator is just an object that's a lot like a pointer. It's actually a full object, but it operates like a pointer. The other thing that's nice about iterators is that, unlike pointers, they've been overloaded for addition. So if I have an iterator that's pointing to the beginning of a list, and then I take that iterator and I add 1 to it, the iterator is now pointing to the second element of the list, right? Which in this case would be index 1, right? The indexes in vectors work exactly the same way as they do in arrays. So we start with index 0, which is our first element. This is only going to become important because, remember, that list that we created when we displayed it started with 1. And the reason for that is that's how all lists work in like human worldness, right? Like nobody ever starts a list at 0. You always start the list at 1. It's the first item. So we may have to do a little bit of math to make sure we're removing the right item. And I have messed this up before, so you got to picture it in your head pretty well. So first thing we're going to do is we're going to essentially say, well, actually, we just have to call the erase on the right thing. I've been given an integer. That integer is the ordinal position of the item in the list. So if you say 2, you want to remove the second item in the list, which will actually be index 1 for us. So I need to subtract 1 from whatever number you gave. In fact, if you gave 1, I would want to subtract 1 and choose 0. The other thing I might want to do is kind of protect ourselves by not letting you choose like a number that doesn't exist. I'm not going to worry about that here, but it may be something for you to think about. Regardless, I need to subtract 1 from the number you give me in order to find the right index to remove. So items.erase, this is going to be very quick. All we have to do is create the iterator. We can create an iterator. I might as well start at the beginning because that makes as much sense as anything. So items.begin is going to be an iterator that points to the first element of the list. But I want to add on to that, and I'm going to put this in parentheses because addition and subtraction are at the same level, but they go left to right. So I want to make sure that we subtract 1 from I, the number you sent me, before we get there. So I want to add I minus 1. Hopefully this makes sense. If you send me 2, you want to remove item number 2, that means I want to remove index number 1. So I take items.begin, which points at index 0, and I'm going to add to it I minus 1, which in this case would be 2 minus 1, which would be 1. So I'm going to add 1, and that will give me the second element. Because I'm pointing to the first element, I'm just moving up 1. If you put in 1, then I minus 1 would be 0. I'm going to add 0 to begin, which will be the first element, which is exactly what I want. One line should do it all. All we have to know is that we get the iterator with the position of the element that we want to remove, and then we just have to alter it by the amount that you gave me, given that I didn't start our list at 0, which may have made our programming easier, but would have made your application look weird. Now, mark as purchased. Going to kind of work the same way, except here I can actually just use indexes, right? So here, mark as purchased list. Actually, probably could have just toggled this too, but it's all right. Mark as purchased, and toggle would just mean I choose the same option and it just toggles whether or not you put the X or put the space, right? Whether you purchased it or unpurchased it. We'll have 2 separate actions for this. So mark as purchased, all I have to do is say, I want to go to items, sub, and it's going to be the exact same thing. You're sending me I, so I actually want I minus 1, right? So if you send me 1, I actually want items sub 0, so the first element, dot purchased, and I'm going to set that to true because you just marked it as purchased. Done. That part's easy. Mark as unpurchased. If you wanted to, you could just copy and paste that line because there's only going to be one part that's different, and I'm pretty sure you know what it is. Items sub I minus 1, oops, dot purchased equals false. So that will set it to false. If you want to do the toggle thing with just one selection, you would just say items sub I minus 1 dot purchased equals not items sub I minus 1 dot purchased. In other words, whatever it was before, just not it. So if it was true, it'll be false. If it was false, it was true. And that will just toggle it with one action. We'll keep them separate. For the record, I also like devices that have separate on buttons and off buttons because one button used to work in theater. Like when I want to make sure this thing is being turned off. I don't want to hit it, question whether or not it's being turned on, hit it again, and then turn it off. Separate buttons are always a good thing. Anyway, so there we go. Mark is purchased, mark is unpurchased. Now we have to go to the main event, the actual input and output of our list. Now, although I have load first, and although we will load first, like in our program, I'm not going to implement load first, right? Load, the problem with load is, in order to read something from a file, I need to know how it was laid out in the file, right? I have to know like how everything was arranged. If I don't know that, then I can't read it properly. So I haven't made any of those decisions yet. I mean, I have an idea. I think we're just going to use comma-separated values, but I don't want to assume that. So what I'm going to do instead is go ahead and write the file first, even though we're going to do it second, so that I know how I'm arranging it, so that I can go back and actually, like read it correctly. Okay, so we're going to start with store, in other words. So I'm going to put list here. It's a member of the list class. Replace that with some curly braces and start to implement store. So the first thing we have to do when we're writing a file is create an output file stream object. So output file stream object. I'm just going to call this out file. Maybe I should call it fout. No, I'm not going to call it fout. Cout would be console out, fout, file out. Regardless, out file, whatever you want to call it. This is going to be the object that we're going to use, much like cout, but instead of writing to the screen, we're writing to the file. They work exactly the same way. In fact, cout is just a stream object, just like an output file stream, except that it attaches to the console. Okay, so then I can open up any file I want here. What I'm going to choose to do is, we're not going to do any sort of relative paths or absolute paths. I actually want to store this file in the same place as all of my other files, so I can actually see it here in CLion without having to go through my, file structure, my Explorer window or whatever. So I just need to give it a name. I'm going to choose grocery data.txt. And the reason I'm choosing .text is just so that it's a plain text file. It can be opened with, CLion. It can be opened with, text edit or notepad or whatever you've got. So you can actually alter it and do stuff like that. Next thing I need to do is check to see if it's open. So if outFile.isOpen, what this does is it basically will return true if outFile is open. Now, why wouldn't it be open? There's one case you will all run into when you first run the program for the first time. And you can see over here, that file doesn't exist. So you can't open a file that doesn't exist. So that means we need to create the file. But beyond that, what if there was an issue, right? What if, I don't know. Chances are we're going to try and load before we store. But if for some reason you can't write to the file, you don't have permission to write to that area, you don't have enough hard drive space to create the file, whatever it is, that's going to return false. And so then I'm not going to do all this work that isn't going to actually work and cause errors. So it's a good idea to check just to see, is the outFile.open? It's not quite as vital as it is with load, because at least with store, if the file doesn't exist, we can write it. When we're reading a file, if the file doesn't exist, we can't read it. We actually have to do something else, which in this case will just be leave our vector blank, which is fine. So next thing we've got, I need to go through my tasks and actually write to the file all the information for each item. That means I need to go through all the different tasks in my grocery list. I can do that in a couple different ways. I could use an iterator where I'd want to start with, file.begin, go so long as, wherever we are, not equal to file.end, and then, so create our own iterator, have it point to file.begin, or not file.begin, but items.begin. Go so long as that iterator is not equal to items.end, and then just increment for each one. And that will give me a reference to each one, and then I can just use the star to essentially dereference the pointer, or the iterator in this case, and get the item itself. That works. I think it's going to actually be a little bit cleaner if we keep it easier and we just use index values like we would for arrays, which you can do as well. So either way works. Maybe I should do it both ways. Maybe. Anyway, for right now, we're just going to start with inti equals 0, I less than, and here we have the advantage that vectors, unlike arrays, know how big they are. They know how many elements are in them. So all we have to say is items.size, remembering that if there's 5 elements, then items.size is 5, but the indexes 0, 1, 2, 3, 4. 4 would be my largest, so I say I less than so that I never get to 5, right? I don't want to do less than or equal to. I'll end up going out of bounds. And then just I++. So now I've got the ability to go through my vector and choose all of the items that I want to write. I just have to write. And I'm going to use outFile exactly like I would cout. So first thing I'm probably going to do is the name. So let's say items sub I dot name. And then I'm going to write a comma. We'll do comma separated values. Why do we do comma separated values versus like spaces or something else? It's because some items may have spaces in the name. We would want to choose something that is a character that would not exist in the name of a grocery store item. Most names do not have commas. You can't do apostrophes because some things have apostrophes. You can't do, hyphens because some things might have hyphens. Can't think of something with a hyphen, but I know there's a product I must buy that has a hyphen in it. Point being, commas very rarely are seen in names. If you think you might get a comma, you might want to choose a really weird character. You can choose any character you want, so long as it would not normally appear in a name. Next thing I want to put is so if I print a Boolean to a file, I'm pretty sure I know how that's going to get placed, but I don't necessarily want to depend on that. So for my Boolean, I'm actually going to write a 1 or a 0 so that I get to control what's putting into the file, so I know what to look for when I get it out of the file. Because I only need to print either a 1 or a 0, this is going to be the second time I've used a ternary operator in this project. I'm going to just use a ternary operator. And it's going to be based on items sub I dot purchased. If I have purchased, then I want to print a 1 for true. And you notice I'm printing the string 1 because I'm actually writing characters to a file, right? Sorry, I put a comma there. Colon 0 for false. So I'm going to write a 1 if it has been purchased, or a 0 if it hasn't been purchased. And that's how I'm going to represent my Boolean, 1 or 0. You can choose anything you want. Remember, whatever you choose for your file out doesn't matter. Just now you would know when you're going to load, you know what to check for. You can make it anything you want so long as you know how you meant to do it. All right? With that, we're done. Now, I would want to put a new line here. I'm not going to. And here's the reason. If I put a new line character at the end of every single line, I will have my last item, I write the file, and then I do a new line character, which creates a new line before my end of file character. And so in C++, that often ends up, creating an extra ghost item at the end of your list every time you store it. I don't want that. Instead, what I want to do is only do the new line so long as I'm not at the last item. So how do I do that? Easy, I just check to see if it's at the last item. I mean, like, let's not make it super complicated. If I is less than items dot size minus 1, right? Because I will never get up to items dot size, but on the last one, where it's, there were 5 elements, when it's at 4, which is my last item, I don't want to write it. So I only want to write the new line character if, for all the items except for the last one. So anyway, here I'm going to just see out a new line character. Again, you could do inline if you wanted to. All works the same. Oh, hopefully you guys caught that as I was doing it. I have to write it to the file, not to the screen. I'm writing it to the out file object. All right, seems good to me. So then, last thing we need to do after that for loop is just do outFile.close. Now, closing the file when you're writing is fairly important. Because remember, we're not writing to a file. I keep saying that we're writing to a file because you might as well think of it as that. But what we're doing is writing to a buffer. And so then that buffer is an object that's being run by the system in C++. And I don't know exactly when that buffer will be flushed and the file will actually be written. I can't be guaranteed it will be flushed until I close the file. That will definitely flush the buffer, actually write it to the physical device on your machine, and then I know it's done. So outFile.close, it's done. I know that I'm good to go. I have an if. I should probably also have an else. Now here's the thing. I don't really know what would cause this at this point, so I'm just going to actually write to the screen and just say error writing to file. Yeah. Done. Actually, I broke the rule I said earlier. /n. Done. So that's just going to give us a message, like a little error message real quick to say, hey, there was a problem. We can figure out what to do from there. It may help us in our troubleshooting, maybe. Okay, so now that I know exactly how it's going to be listed, right? So it's going to be bread, comma, 0, new line. Milk, comma, 1, new line, right? That's going to be my format. The 1s and 0s tell me whether or not it was purchased. I know what the layout is going to be. Now I just need to actually load it when I want to load it. So when we first open our app, we should attempt to load the previous list, right? That's the idea, persistence. I want to be able to shut this program down, start it up again, and we're right where we left off. So to load something, I am going to create an in-file object, right? Which should be an input file stream object. By the way, there is just a file stream object that you can switch modes and either read or write. But by sticking to like an output file stream object and an input file stream object, it keeps you from doing anything that's kind of, you're just in one mode. It's a little bit easier to not accidentally mess things up with a call that you didn't mean to make. But whatever. I'm going to call it in-file. That'll keep it consistent. And I can, by the way, you can also do this with a separate call to .open and then put the name of the file in after you've created the object. But the constructor for an input file stream object allows you to just open one immediately. All that matters is that it's the exact same name as the file you wrote. See, once again, like you have to know what you wrote in order to be able to read it. So those two names have to match. You can choose any name you want for your file, just as long as they match, right? Yeah. So now I've got my file open. I'm going to say, well, now I should do the check if open, right? So if infile dot is open. Now remember, this is the important one, because with writing a file, if I can't write to the file, like there's something going on that won't allow it, don't have permission, don't have room, whatever, then I'm just going to print an error message. For this one, I mean, we're not going to do a whole lot, but what we're going to do is, like, if I can't read the file, if the file doesn't exist, then I just need to go on with my day, but assume an empty array list, right? Because you can't read a file that's not there. So this one's a little bit more important, even though in this particular application, we're not going to do a whole lot in the else. We're just going to let stuff go. So then, now I'm not going, so when I was storing my information, I was going from my vector, taking all the data from the vector and writing it to a file. Loading is just the opposite. I'm starting with my file. I need to traverse my file and put all that information back into my vector. So what I have to do is go through the file. The way you go through the file, or the way you traverse a file, is usually with a while loop. The reason we use a while loop as opposed to a for loop is because I don't know where that file is going to end. You might have 100 items on your list. You might have 5. So I'm just going to say while this file is not at the end of file, and you can do this in a couple different ways. You can say while in file, while not in file dot end of file, right? So that's one way of doing it. And so that will just loop through and actually give you each line as you're going through. You could do that. There's a couple of different cases where this is not going to give you what you want. I can't think of them off the top of my head, but I just know that in general, .good is probably used more often. So get rid of the not though. This is while in file .good. In other words, you can read the line exists, we're not at the end of file yet. So we're just going to kind of loop through the file line by line until we get there. So now once we're there, we can do getLine calls to get information out. So the first one, what I would expect to see at the very beginning of the file is the name of the first item, right? So I'm going to do getLine. Now getLine tells you where you want it to come from and where you want it to go to, right? So I need to have a place to send it. I don't have that yet. But I know where I want it to come from. I want it to come from the end file. Where do I want it to go to? I want it to go to a brand new item object, which I have not created yet. So somewhere up in here, do it right here, it doesn't really matter. Item, noob. I'm terrible at naming things today. But while in file, and so then this is a string that I'm reading, because that's what getLine returns, a string. So I can actually just send that straight into whatever it is I'm looking for. Will it allow me to do noob.name right there? Looks like it will. Okay. Just want to make sure I didn't have to create a temporary string like I have to do with a lot of other things. So then noob.name in file. Now here's the thing. I want to read up to that comma and not past it and not include the comma. So getLine does that for us. It's the reason why I prefer getLine for any sort of reading from stuff, right? By default, getLine is going to grab all the way to the new line character. I don't want that. I just want it to go to the comma for this one. So I'm going to put in that optional third parameter. It says DLM, it's the delimiter, right? Remember, these are just labels. I didn't type them. C-line's putting them in for me. So I'm going to grab that delimiter and then basically get rid of the delimiter. So we're not going to include the comma in what we're grabbing, but we're going to grab everything up to the comma but not including it, but we're going to get rid of the comma off of our file buffer. So I've just got the name before it. I'm going to take that, put it into noob.name, and we're good. Now I'm at the character right after the comma. Now I know that's going to be either a 1 or a 0. So at this point, I need to actually put it into something. In this case, let's create another thing. I need to get a string, so we're just going to call this temp. I feel like I should always just create a string temp just in case. And I'm going to say that temp is equal to the get line from infile. Oh, hi. I'm using this wrong. I just have to say infile, send it to temp. So where's it coming from? Where's it going to? And what's going to be the delimiting character? Now in this case, it's going to be the new line character. That is the default. I technically don't have to put that third one in. I could just leave it as is, but you know, why not? But I haven't actually written anything to noob yet, my new item that I'm creating. So what I'm going to do instead is say if the s2i of temp is equal to 1, like there's an easier way of doing this. Nah, that's fine. If you find a more elegant way, feel free. So the s2i of temp is equal to 1. If that is indeed a 1, then I want noob.purchased to be equal to, if it's 1, it should be true. Hi. Else, we want to set it to noob.purchased equals false. Oh, there is such a better way of doing that. Do I want to? Here's the thing. I know that the s2i is going to be a 0 or a 1 because those are the only things that we're writing to the file. 0 and 1 already have a value, right? So I don't actually have to do any of this. I can just say noob.purchased equals the s2i of temp. So now that may not seem right. I'm taking an integer and setting it into a Boolean value, but remember, what's happening here for this assignment is the right side is being evaluated. And in this case, because it's a Boolean, it's being evaluated to determine whether or not that's a bool. So anything that is not 0 is considered true. So if the s2i for temp comes back as anything, any number other than 0, which includes 1, noob.purchased will be true. If the s2i of temp is 0, then noob.purchased will be false. And so, yeah, I didn't have to do a branch at all. All right, now, so now we've got our noob. The next thing I need to do is to push that object, or at least a copy of that object, to my vector. So here, because I'm just going to reuse noob over and over again in this loop to create a new object and then copy it over to the vector, copy it over to the vector, copy it over to the vector. So I'm just going to say items dot pushback, and that'll keep the order that you have in the list, noob. Right? So then I push noob to the vector. Once it's in the vector, that's fine. Let's start the line over again with the next line. Because we've already gotten the new line character, so the next part of the file that we'd be at is the beginning of the second line, assuming that that is still good. If it's not good, then we stop the loop and you only had one item. Yeah, that makes sense. Okay, good. Once we're done with that, we can just say, because we had opened the file, now I just want to say infile.close. Closing when reading isn't nearly as important because you've already got all the data you want, so who cares? You're just going to end up writing at some point. But it's always good if you open a file to close it, especially if you're dealing with things that might have different threads in them. But that's a much later thing. So now, what happens if the file doesn't exist, which is going to happen the very first time you run the program. The very first time you run the program, there is no file there, so you're going to read it. What do you want to do? I can say else, and then just cout no file to read. Sure, why not? Now, would I actually want to put that there? No. Because then the first time your user uses the application, it's going to say, no file to read. They're going to be like, oh no, what went wrong? Nothing went wrong. We expected there to be no file the very first time you run it. But eventually you'll end up storing the file and then it'll be fine. But for that now, I'm just going to put that there so you can at least see it happen the first time. Other than that, I think we're good. The next thing with this is just going to be, where do I actually want to load and store? Now I told you that I'm going to create an interface in main for all of this. And I could actually create load and store options in my actions. But that seems rather old school. What I'd rather do is just immediately store the information every single time you make a change to the list. So that's fairly easy, right? I just have to call the store function every time you make a change to the list. Well, I've got everything you can do to the list right here. So let's ignore load and store and say Marcus unpurchased. Does that change the list? Yes. This arrow store. Marcus purchased. Does that change the list? Yes. This arrow store. Store. Remove item. Does that change the list? Absolutely. This arrow store. Basically, anytime you do something that changes the list, add item. This arrow store. I want to store that new information. Displaying the list actually doesn't change the list, so I'm going to leave it out of there. There we go. Now, where do I want to load? I want to load at the very beginning of my program. And the very beginning of my program starts with main, and so that's going to be the next thing we do, actually creating an interface to use this entire list object thing we've created. All right, final part here, assuming that when we test this, it actually works. So we need to actually create an interface. First thing we're going to do is start including a bunch of stuff that we need. We need strings probably. We're going to need to use vectors probably. Sorry, just vector. We need to include, well, I need to include grocery list. No, just list.h. We kept it simple, and I keep trying to make it more complicated. I'm also going to need IO. Oh, I already have IO stream. So I've got IO stream, string, vector, list.h. Oh, I'm going to need fstream. If we need something else, we'll figure it out as we go along. Using namespace standard, so I don't have to write all that stuff in. And boom, here we go. We've got our main function all set up. This is going to be the first thing that happens when we run our program. And so what is the first thing I want to do when we run our program? I want to create a list, and I want to load that list from the file. So list. Is that going to be okay? I feel like that's something that Google would do, so sure. List dot load. Done. I don't have to worry about there being multiple lists. Again, load could possibly take a string, and that would then load a specific file name based on that string. I don't have that. We're just going to create a list, load that list. There's only one file. It's always going to be in the exact same place. We are good to go. So next thing I want to do is I want to display a list of things, right? I want to display the list as well as a menu of options that you have. So first thing I'm going to do is let's put this into a loop. That way it's going to continually go on and on. So I can say list.display, so display the list, done. After that, I'm going to actually create a little menu. So cout, and maybe for the menu, I just use, oh, nice. Okay, hold on. That happens to be still stored in on my clipboard. So I'm just put another one of those lines for the menu. It doesn't matter if you have the exact same length of line or not. But again, if you're a little OCD, why not? And then I want to display the things we have to do. Okay, so let's see. I've got a new line. And I'm going to give the options numbers as well. So this is going to be one.addItem, new line. Again, I don't have to put these all in separate lines. You know, what gets displayed is based on the new line characters you insert. But I'm just sending everything to one cout, and I like having it on separate lines so that it kind of looks like what the menu is going to look like. So we can add an item. We need to mark item as purchased. I feel like if you're better at English than I am, you're going to be, oops, get rid of that capital A. You're going to be able to figure out a better way to do this one. Oh wait, no, I can just say unmark. I think last time I said mark item as unpurchased or something like that. I should say unmark item as purchased. That's the better English way of saying it, kind of. It still sounds horribly awkward to me, but whatever, it's good enough. And then we also have a remove. So remove is not marking it as purchased, which would tell you, oh, it's in my cart. It's removing it as, oh, no, actually, I don't really want that item after all. Maybe I should make that option 2. Ignore me while I feel it just feels like it belongs next to add item. So add item, remove item, mark item as purchased is now option number 3. Option number 4 is unmark item as purchased, and option number 5 is exit. Yeah, I like that. And then we'll do one more of these dealios, and the prompt enter choice, or whatever you want to use for a prompt. I'm not going to put a new line character on the end of that because I like my choices to be right there next to the prompt. And then you'll hit enter. So, okay, so we've got the cout, so we've displayed the list, then we display the menu. Now we just actually have to get something. So I'm going to use a get line. It's going to come from the cn, and it's going to go to temp, which I haven't created yet, but that's fine. Up here, after we create our list and load it, just string temp. It seems helpful. And then I'm going to, well, I do actually need to create a temporary integer as well. So I don't like creating variables inside of a loop, even though your compiler is actually going to fix that for you. But I'm not declaring a new variable every time we iterate the loop. So I'd rather declare it outside and then just, use it inside the loop. Again, if you were to actually create that inside, it would be just fine. But getLine comes from temp. Choice is going to be equal to the S2 I of temp. And now that I have a choice, well, I guess I need to potentially switch on that choice, right? So switch choice. So now basically you're going to give me 1, 2, 3, 4, 5, so I can just do different cases that match the choices that you have. So case 1 means you want to add an item. So I'm going to say something like cout enter item. Then I'm going to do a get line to take that from the cn, move it to temp. No reason to not just reuse that same string over and over again. It's called temp for a reason. And then I'm going to, I guess I have temp. I can just go ahead and do it. So we're going to call list.addItem and send it temp. Right? Yeah. Make sure we put our break in because I'm using a case. I always use switches with cases for menus. Don't know why. They're just like, you could do this with a big branch of if-else statements, but it just feels easier. Like when I think of switch statements, I often think of menus like this. Next thing we're going to need to do is the remove an item. So remove an item is going to be cout enter item number to remove. I feel like there should be capital R there. Same thing, we're going to be doing get line from the cn to the temp. And then I need to, I mean, at this pace, we've already switched, so I could actually reuse choice. I don't really need to. I can just send it. So let's do list.remove item. And then the thing I want to send is the s to I of temp, but you gave me 2, and I actually want to, oh no, wait. We already calculated for that. Never mind. I'm just going to send the number. We already figured out the -1 inside the remove item function, so we don't need to do it there. All right. I like it. Basically, we're just going through and having each one of these options call one of our functions, usually sending a little bit of information. Iterator remove, perfect. So then next is going to be case 3. Case 3 is mark as purchased. So cout enter item number, enter number of item to that was purchased. What is that purchased? Sounds good to me. Get line, again, coming from the cn, putting it into temp. That's how I'm getting my user input. And so then here, the enter number of item purchased. I purchased item 5. I just want to send that to list dot mark as purchased and send it the s to I of temp. Case 4. Copy, paste. Again, we could have done this as a toggle. Other than I need to change the English. Enter name of item not purchased. Yeah, sure. Only done by a mistake, probably. So cn, temp, and then I want to do mark as unpurchased. I mean, you know. again, better English might make it better, but oh, and also getting too used to Swift. Put breaks in for all of these. Don't put any beaks in, just breaks. All right, so that's case 4. Case 5 was exit, which to me just means, well, that's my default case, right? Just get out. So basically, if you put in anything other than 1, 2, 3, or 4, then we're just going to exit the loop. You're not going to, you're choosing exit, whether you want to or not. So I'm going to say repeat equals false. Now, I have not created repeat yet. Again, I just don't want to create it in here. So I'm going to go up here and say bool repeat equals true. There's an argument that I should also put default values for these, but I know it'll be fine. So repeat equals false means that this is the way that we're going to exit our loop. And I actually don't have to put the break in for this one because it's the last one, but regardless, why not? So there's my switch. That means that this curly brace is the end of my do list, right? So it's a do while list. So I'm going to say while repeat. So keep doing this while repeat. Repeat started as true. It's going to keep doing it until you choose to exit. Anytime you make a change to the list, we store the list, and we load the list at the very beginning of main. I have a feeling that's pretty much it, other than maybe a little message here when you do decide to quit. Exiting program. Goodbye. Why not? So we'll at least see that to know that we did that right. So if we've done everything we needed to do, here in main, we created a list, we loaded that list from a file if it exists. We created a couple variables that I'm going to use here later on. Then we created a do while loop that's always going to display the list using the method to display your grocery list. Then have a little menu stuff to add item, remove item, mark as purchased, mark as unmark as purchased. And then you enter your choice. We switch on that choice from the menu, and then we either have you enter the item that you want to add to the list, whatever the number is. And we're basically just calling each of those methods that we created, or each of those member functions for each different possibility. Exit the loop when we no longer want to repeat, and then we exit the program. This should work. I'm going to hit the play button and cross my fingers, and hopefully it builds properly. We've made no errors. The chances of that are slim, but well, at least it runs. And we can see it says no file to read. It says no file to read because it was our first time running the project. The file doesn't exist yet. Again, we probably should not have put that message because that's going to give people a bad, like, what's wrong? What's wrong? There's nothing wrong. Your grocery list is supposed to be empty. So let's start with adding an item. So I'm going to add an item. What am I going to add? I'm going to add bread. Awesome. So now it displays my grocery list and it says bread with a blank checkbox here because we haven't purchased it yet. Let's add another item. Milk. Done. Add item. Coffee. Bread, milk, coffee. We are good to go. So now I've got 3 items on my list. Let's play around with some. Let's remove an item. I want to remove item number 2, which is milk. Now I just have bread and coffee is now item number 2. So far, working the charm. Add another item, which will add it to the end of the list. We will say cereal. Bread, coffee, cereal. So far, this is working well. Let's see here. We should mark an item as purchased. So let's mark an item as purchased. Of course, I've already purchased my coffee. Boom, we get that big X in coffee to show that that is indeed working. Let's see here, we can unmark an item as purchased. Well, here, let's mark another item as purchased, just so I have some variance when we actually store the file, or try to load the file, I should say. So let's mark an item as purchased. Let's also mark, sure, the serial is good. Let's unmark an item. We're going to unmark the serial. All right, so we're back down to only coffee having been purchased. All of our actions seem to be working as we're creating the grocery list. The last thing we need to do is exit. All right, so exiting program, goodbye. Very good. Now, if I look over here, where is this? It should be under your CMake build debug. So under CMake build debug, this is where your actual exe file exists. So this is the executable right here. If you were to actually go to your file system, you could find that under the debug folder and, I don't know, drag it to your desktop and be able to run this program anytime you wanted to. Other than it would also store the data file to your desktop because we didn't put a path there to store it in a particular location. But here is grocerydata.txt. If I double click on that, bread, comma, 0, coffee, comma, 1, cereal, coffee, cereal, comma, 0, right? Exactly the way we thought we would have it formatted. So we read up to the first comma, that's the name. We read up to the new line, that's the true, false, did we actually purchase it or not? Of course, the only way we'll know for sure is if I run this again, we should already have items in our list. And we do. So bread is still showing as unpurchased, but on the list. Coffee has already been purchased and is on the list. Cereal, not there. We got rid of something. I can't remember. We got rid of the milk. So yeah, so we have persistence. I can stop this program as many times as I want. I can run it again. And when I run it again, my list is still there because it's being held here. And if I decide to add another item, let's say donuts, and add another item, and we'll say Pepsi, and suddenly I'm getting into junk food. I want to say that I marked an item as purchased. We'll do that for the donuts. Awesome, now I've got this. Then I just want to exit, so I exit, and you can see this file was changed. Technically, that file should have been changed every time I made a change. I just don't think CLion updated it, like updated the display of it until the very end. If you wanted to, you know, play around, peanuts, comma 1. You could say, I don't know, chicken, comma, whoops, don't put a space in there. It's not expecting it. Don't hit return. There should only be 7 lines here. Save that file. Then when I run this again, hey, look, I got peanuts that have already been purchased and chicken that hasn't. All right, so in fact, if you've ever run a Linux system and somebody was saying, oh yeah, go to this file and like this huge long text file and find something and set that to =1 or something, that's exactly what you're doing. You're just manually editing the text file to switch how the program gets loaded or what your preferences get loaded. So we've got a full working grocery list. I will upload these files so that you have them to sort of reference and go back to. But then that should be hopefully a good foundation for you to be able to finish your project this week. Yeah, that's all. Have a great week.